Welcome to Thuma Mina Teaching. This is your first grade 9 natural sciences lesson for term 2. In order to fully participate, you will need a pen, a notebook, and your periodic table. In this lesson, we will revise the organization of matter, take a closer look at the periodic table of elements, analyze compounds, and study chemical reactions. I am Nadia Gr9 and this is my Thuma Mina Teaching. Let us revise what is matter. Matter is everything that has mass and volume, which means everything that takes up space. Can you see anything in your surroundings which takes up space? All matter is made up of elements and compounds, and as we know in grade 8, elements and compounds make up pure substances. Elements are arranged on the periodic table according to the atomic number. Some elements include hydrogen, nitrogen, helium, and oxygen. In grade 8, we learned that compounds are made up of 2 or more different elements. These elements bind to one another in different ratios, and this specific ratio marks it as a compound. Compounds can only be separated by means of chemical separation techniques. Examples of compounds include the water that we drink to the salt we use at the dinner table. Salt is sodium chloride. Can you think of what water would be? Let us take a closer look at a water droplet. When we look at it, we see that there are various amounts of molecules, and these molecules are made up of 3 atoms, 2 hydrogen atoms and 1 oxygen atom. The ratio therefore is 2 to 1. In grade 7, we learned about mixtures, and mixtures do not present themselves in a fixed ratio. Now let's think about it. When I take iron filings and I mix it together with sand, there is no ratio involved. And when I try to separate them, I will use a separation technique that is based on their physical properties. I know that iron can be magnetized, and I will therefore take a magnet, wrap it in a cloth, and hold it over my mixture, thereby separating the sand and the iron filings. In grade 8, we learned about the atom and its 3 subatomic particles. We have the electron that moves at the speed of light in the orbital, creating this electron cloud. Remember, the electrons are negatively charged. In the core, we find the nucleus, and the nucleus is made up of protons and neutrons. The protons are positively charged, and the neutrons are neutral. The neutrons and the protons together are called nucleons. Nucleons is what makes up the mass of my atom, and I will find it on my periodic table as the atomic mass. Remember that all of the matter around us is made up of elements or compounds. The elements can be found on the periodic table of elements. These elements are arranged according to their atomic number, but we can also separate the metals, the non-metals, and the semi-metals from one another. On the left-hand side of my periodic table, I will find all of my metals. Examples are sodium, magnesium, lithium, and the list goes on. On the right-hand side of my periodic table, I will find all of my non-metals. And these are things you know: the carbon that you use to make your fire at night, the oxygen that you breathe in, and the fluoride that we use in our toothpaste. In between my metals and my non-metals, there's a zigzag line, and on both sides of the zigzag line, I find my semi-metals. Remember, my semi-metals contain both properties from my metals as well as my non-metals. Examples of semi-metals include silicon and arsenic. And remember, arsenic can kill people. Let us take a closer look at metal elements' properties. When we look at metals such as copper and iron, we find that they are shiny. They conduct electricity well as heat, which is why we make up our pots from them. Another characteristic is the fact that they are plattable, meaning I can shape them into any shape I want without breaking the element. Non-metals such as sulfur and carbon are not shiny. They do not conduct electricity or heat very well, and they are very brittle. If I bump it, it breaks. So now we will take a look at the organization of our periodic table. There are many rows and columns on the table. When we look at the columns from top to bottom, we will call them groups. Elements that are in the same group often share the same chemical properties. So elements that are part of the same group include hydrogen, lithium, and sodium. They share similar characteristics and will therefore behave similarly in chemical reactions. The horizontal rows from left to right, we call them the periods. Lithium, beryllium, and boron are in the same period. From group 3 to group 12, we find the transition elements. In grade 8, we studied the 7 diatomic elements. And remember, a diatomic element is where two identical atoms bound together. The 7 diatomic elements include iodine, bromine, chlorine, fluorine, oxygen, nitrogen, and hydrogen. An easy mnemonic to remember is I bring clay for our new house. The starting letter of each word indicates the symbol of the diatomic element. You could be asked the names of the groups on your periodic table, and there are only a few to remember. The first group we call the alkali metals. The second group is the alkali earth metals. Group 17 are my halogens, and in the last group, group 18, are my noble gases. Each element found on the periodic table is unique in the sense that they all have a unique type of atom. Each atom is made up of protons, neutrons, and electrons. The combination of electrons, protons, and neutrons make up the unique properties of each element, and therefore they differ from element to element. So let us zoom in on one block on the periodic table. In one block, we will find a symbol, atomic number, and a mass number. In our example, the symbol is C, and C represents carbon on the periodic table. The mass number is equal to 12 in our example, and we must remember that the mass is located in the nucleus, where all the neutrons and protons lie. The atomic number is equal to 6, and the atomic number always indicates the number of protons in my element. When we deduct the atomic number from the mass number, we will be left with the number of neutrons in the element. Therefore, 12 minus 6 is equal to 6. There are 6 protons and 6 neutrons in an atom of carbon. According to the arrangement of the periodic table, carbon is located in the 14th group and in the second period. In our other example, we see the symbol O, and O represents oxygen on our periodic table. So the mass number is equal to 18 in this example, which indicates the protons and the neutrons located in the nucleus of my oxygen atom. The atomic number is equal to 8, and this is the number of protons located in the nucleus. Once again, if I deduct the atomic number from my mass number, I will be left with the number of neutrons in the core. Therefore, 18 minus 8 is equal to 10. I have 8 electrons, 8 protons, because remember, my atom is neutral. And I have 10 neutrons located in the nucleus of my atom. Oxygen is located in the 16th group and in the second period. Here's an opportunity for you to try and decipher an element. So take your periodic table and see if you can answer the questions. So again, the symbol is B. The element it represents is boron. The atomic number is equal to 5, which is the number of protons located in the nucleus. The atomic mass is equal to 11. Remember, the mass indicates protons and neutrons. If I want to know the neutrons, I need to take the atomic mass and minus the atomic number, which is 11 minus 5 is equal to 6. There are 6 neutrons located in the nucleus of my atom. Boron is located in my 13th group and in the second period. Remember, if we look closely, boron is also located on the zigzag line, which makes it a semi-metal. When we say all matter is made up of elements and compounds, we will now analyze these compounds that matter is made up of. When the atoms of two different elements bond together, we find that a compound forms. All compounds can be written as a formula, and in our example, we are going to take a closer look at carbon dioxide. Remember, carbon dioxide is the air that we breathe out. The chemical formula for carbon dioxide is a capital C, a capital O, and a small 2 at the bottom of the O. This small 2 is called the subscript, and it indicates that the two oxygen atoms are connected to the carbon atom. From here we can also see that there's a clear ratio of 1 to 2. The total number of atoms in this compound is 3, 1 plus 2. When we name compounds, there are certain rules that we need to adhere to. So when we name a compound only consisting of non-metals, only non-metals, then we need to add a few prefixes. Our example, we just used carbon dioxide. Carbon and oxygen are both non-metals. I'm using 2 oxygen molecules, which means I need to use a prefix. The prefix for 2 is di. Therefore, carbon dioxide. When there's only 1 oxygen molecule, I will call it carbon monoxide. Mono indicates 1. In this example, sulfur trioxide, we see there's a S for sulfur and 3 oxygen atoms. Tri indicates 3. So the prefix tri is to indicate that there are 3 oxygen atoms in my compound. It is important to note that this rule only applies to compounds made up completely of non-metals. For example, magnesium chloride. In this compound, magnesium is a metal. Therefore, I do not say magnesium dichloride. It is simply magnesium chloride. Another rule when naming compounds is that we mention the element located most to the left first, and this rule applies to all compounds. Please make sure to study the following common compound groups that often appear in chemical reactions: hydroxide, nitrate, carbonate, sulfate, sulfite, and phosphate. In this example, we see a compound made of 3 elements. Can you identify the 3 elements? So the 3 elements are calcium, sulfur, and oxygen. But when we look closely, we see that the sulfur and the oxygen are one of our specific groups that we just mentioned. Can you identify which group it is? It is sulfate. Therefore, when we name our compound, it is calcium sulfate. Go look on your periodic table. Calcium is located most to the left. Therefore, it is mentioned first. From the formula, we can also deduce the ratio. 1 calcium, 1 sulfur, and 4 oxygens. Therefore, the ratio is 1 to 1 to 4. What are the total number of atoms in this compound? 6. Now that we know how to write a compound's name and which elements form part of compounds, we need to know what produces a compound. When a chemical reaction occurs, a compound is produced. A chemical reaction is a process in which one set of chemical substances is changed into a new set of chemical substances with its own chemical properties. When we bake a cake, we must make sure that we have the right ingredients. We need flour, eggs, sugar, and milk. These ingredients must be used in the right quantities or right ratios. Otherwise, our cake won't rise. When we take the cake out of the oven, we can no longer see where the eggs start and where the milk stops. The cake is our final product, and the ingredients that we used were our reactants. The cake has its own unique properties or characteristics and differs greatly from the liquid milk to the slimy eggs. Therefore, baking a cake was actually a chemical reaction. So how do I write down this chemical reaction? Always on the left-hand side, I indicate my reactants. Therefore, the milk, the eggs, the flour, and everything else that I use go on the left-hand side. I do not use an equal sign. It is always indicated by an arrow because the cake went straight into the oven. The product is always written on the right-hand side. This is my final cake. There are 3 methods in which we can represent a chemical reaction. The first one is using words. On the left-hand side, I will write carbon plus oxygen. I will not use the symbols. I will write these words out in full. Make an arrow, and then I will write down my product. In this case, it is carbon dioxide. Not the symbols, only the word. The second method we can use is a chemical equation. Now I only use symbols. Instead of writing carbon, I only make a C. The plus sign and oxygen, which is O. But now you have to remember, oxygen is a diatomic molecule. And I need to make the small 2 or the subscript at the bottom. Therefore, it would be C plus O2. The arrow will show me that a reaction has taken place, and my product will be CO with a subscript of 2. The final way we can show a chemical reaction has taken place is by using microscopic images. In our diagram, we can clearly see the large black carbon atom and the diatomic molecule which represents oxygen. The arrow says again there's a chemical reaction taking place, and my final product would be the image of a carbon dioxide molecule. Let us see how well you can remember the chemistry that you learnt in grade 8. Can you find the following elements on your periodic table? Neon, lead, silicon, mercury, Why don't you try and identify the ratios of the following compounds? Let's try sulfate. This is written SO4. Next up is copper oxide. This is written as CuO. Lastly, let's do iron oxide, and this is written as Fe2O3. Grab your periodic table and identify whether the following elements are metals, nonmetals, or semimetals. First up is copper. Its symbol is Cu. Can you find it on the periodic table? Copper is a metal. It is shiny and can conduct electricity. Next up, iodine. You will find it on the right-hand side of your periodic table, and therefore it is a non-metal. Our third example is calcium. You will find it in the second group. Because it's on the left-hand side, it is a metal. Our final example, boron. Do you see that it's on the zigzag line? Yes, it is a semi-metal. Armed with this new information, try to write down the names of the following compounds. The first one is lithium oxide. Because lithium is a metal, I do not mention the subscript 2 as di. Therefore, it is only lithium oxide. Our second example is sodium hydroxide. Remember, the hydroxide group was one of those important groups that you had to study. Calcium carbonate. It is a compound that is commonly found in seashells. This marks the end of this lesson. I'll see you in the next lesson, where we will be discussing how to balance chemical equations.
We hope you benefited from this video lesson. Our vision at Thuma Mina Teaching is to accelerate access to quality education. And our dream is to see learners across South Africa flourishing academically. We are a non-profit company and we are entirely dependent on public support. We produce lessons at the rate at which they are funded. As soon as a lesson is funded, it is published to the entire growing audience of Thuma Mina Teaching. Please consider taking hands with us in one of the following ways. Share our content with others that can benefit from it. A great way to support us is to find us on My School and to add us as your beneficiary. And consider donating towards a lesson, or ask your company's CSI department to partner with us. We are a PBO, so your donation is tax deductible. Our contact details you'll find on our website www.tmteaching.co.za. If you want to reach out to us, please email us on admin@tmteaching.co.za.